Hey all, welcome back. So today we are going to discuss about conditional statements in behavioral modeling. So we have until now we have discussed like various concepts in behavioral modeling as well as in data modeling and in gate level modeling also. So when it comes to gate level modeling, we will be using gates in order to write our code. Is it or not? And then when it comes to data flow modeling, we'll be using continuous assignment like assign keyword in order to write our code. Okay, now coming to behavioral modeling. Okay, and also in data flow modeling, in order to write our code, what we are using a concept called operators. Is it or not? We have discussed about all the operators also. So based on by using the operators, you will be designing your code in case of data flow modeling. In the same way, when it comes to behavioral modeling, that means, for example, if someone asks you to write a particular code, like these are all our coding styles, you already know that. That means you can design your code based on the designing of the code and based on the complexity of the code. You can prefer either of these three types of coding styles, is it or not? So, if someone asks you to write to design some combinational circuit, or someone asks you to design a flip flop by using a behavioral modeling, okay, then how are you going to write the code? Is that right? Got my point? So, in behavioral modeling, you will be using conditional statements and loops. Clear? So, let me just give you a small tip for you. Basically, in gate level modeling, you will be using gates. Okay, and gate or gate for writing your code. And when coming to data flow modeling, you will use the assign keyword as well as operators in order to design your code. And coming to behavioral modeling, you will be using conditional statements and loops in order to design your code. Got my point? So these are the things. And basically, when it comes to combinational circuits, you will be using data flow modeling and gate level modeling. For example, if you are going to design simple circuits like adder, subtractor, you will be going for gate level modeling. And if the complexity is increased, like if you are going for encoders, decoders, okay, like ripple carry, adders, okay. So basically, when you are going for this type of complexity combinational circuits, you will be coming to data flow modeling in order to write your code. In the same way, when you are designing sequential circuits, because what is the difference between combinational and sequential circuits? In sequential circuits, everything is based on clock and reset. Is it or not? You need to generate the clock and you need to generate the reset in order to design your sequential circuit. So when this comes to sequential circuits, mostly you will be using behavioral modeling. That means behavioral coding style in order to write your circuit. So in this behavioral coding style, what is the important thing that you need to do? You need to know about these conditional statements. Conditional statements are nothing but if else statements, case statements. Okay, so all these are conditional statements. And when coming to loops, like while loop, forever loop, okay, so all these are loops in case of behavioral modeling in verilog. Okay, so may have some knowledge on any other course like C++ and all. So not only C, in any language these conditional statements are common. That means the working of the conditional statement is common, but what is it that differs? The logic, that means where we are placing it is different. That's it. Okay, so the working, this if you know any language like C, Java, anything, this conditional statements working is same in all the languages. So in today's class, I don't elaborate about these conditional statements and all, like they're working and all. But if you want me to elaborate the explanation of this conditional statement, me to give an elaborated explanation on this if else statements and all, you can comment me or pin me in the LinkedIn also, so that I'll be explaining it. But as for now, today we will be seeing how we are going to use this and write our code in sequential circuits. That means we are going to write a sequential circuit code by using this conditional statements. This is what we are going to discuss today. Clear? Okay, so first is conditional statements in conditional. So from the name itself, you would say that conditional statements is you, in order to execute, in order to in order to assign some value into the particular variable, you are giving condition. So until that condition is satisfied, this value is not assigned, or this we can say that this code is not executed. Okay, so this is what conditional assignment means. In Verilog, you will be having like lots of conditional assignments. One among them is if condition. So here if condition, that means if you want only, if you are going to execute only one statement, okay, and if you don't, if you are stick to only one condition, then you will be using if condition. Okay, this is the syntax for if condition. If, for example, if a greater than b, okay, begin, you are going to execute some statements and end. Now what happens? Only if a is greater than b only, then all these statements are being executed. And if a is not greater than b, then this entire block is not being executed. That means all the statements within the block are not being executed. Okay, that is what if statement is. Okay, so this, if you see here, if you have more than one statement, like along with if you are having some more conditions and some more blocks, then what you'll do, you will go for if else if. Okay, if you see here, I have taken two values like a and b, and if greater than, if a is greater than b, I want this display to be executed. Else if a less than b, then I want this condition to be executed, else this statement. Okay, I think I no need to explain more clearly about this, but if you don't understand, you can freely comment me in the comment box so that I'll explain it much more clearly. Okay, so because I don't want to waste your time in yeah, explaining this simple task and also, that is why I'm not explaining it more clearly. Okay, so this is the syntax for else if condition. Okay, we have already seen the program here. So for the syntax, as for syntax, else if, for else if, what is the condition? First you will be writing if block, and how many else if blocks you want, you can enter, and finally you will be giving the default case, which is else case. Okay, so for this again you are having this if and else. Okay, only if you have only two conditions, like if you want, if a is greater than b, I want to execute a is greater than b, else I want to execute a is less than b. That's it, only two conditions. Then if you are going for only two conditions, then you can use this syntax, like if condition, else condition, simple. Okay, but if you are having like more than two conditions, then you will be going for else if blocks. Okay, so now let us see how we are going to design a D flip-flop using this particular if block. Okay, by using the if condition. So if you see here, I think you already know about the sequential circuits, because you already know about digital electronics. We will be studying about combinational circuits and sequential circuits. So this is my D flip-flop. Okay, okay, D is my input and Qn is an output, and along with it, I am taking the clock, because you already know sequential circuits means they will be working on clock and resets. Okay, right? So this is the characteristic table of my D flip flop and truth table. Now, if you come to the truth table, C is my clock. Okay, D is my input. See, clock and D. Now, if you see here, when clock is not there, that means when clock is either in negage or something. Okay, then the D flip flop won't be active. That means the D flip flop will be carrying the output of the previous one. Like if Qn is having some many previous values from K, now when the clock is active, what is happening? Whatever that is there in D, that will be going to output Qn. So that is why always at the rate of passage of clock, begin, okay, whatever that is there in D, I am giving it, whatever that is there in D, I am giving, assigning it to Q, and then end module. Simple. Okay, this is just a basic D flip flop. If I am not using any reset, okay, if you see here, without any reset, this is the thing. For example, if we have reset, that means we are adding one more control to my D flip flop. Okay, along with clock, I am adding some more control to my signal. Okay, condition. So when you are adding control, you need to write a condition. Is it or not? So there comes this particular block. If you see here, if you are adding reset, okay, so I am writing my D flip flop using synchronous active low reset. Okay, this is my program. If someone asks you to write, because based on you can design anything when you are going to design, but when someone asks you in interview in order to write a code for like active low reset, then you should remember that you should give preference to the condition. What is the condition here? My condition is active low reset. Okay, I am writing my code based on active low reset, so this will be my condition. Okay, so the same like module, what are the inputs, what are the outputs, I am going to take everything. Okay, so if here before we have seen that since there is no reset, you are not taking that as input. Now if there is reset, so you are taking that as input. Now at the rate of always at the rate of passage of clock, right? It is fine, then begin. So now what is my condition? Active low reset. So if there is no active low reset, okay, no, not okay, no active low reset, then the output will be 0. So this is my condition. If there is no active low reset, then my output is 0. And else means, what is the meaning of this? If there is active reset, okay, instead of writing this condition, I can just write else. Else means the default condition. Since there are only two conditions here, what is that? Active low reset, not active low reset. So I have given the first condition like not active low reset. So what is the next condition? Just the active low reset. Else, what should be my value? Q equal to D and end module. Okay, if you see this is the block, this is my code. And coming to test bench, so this is the test bench. Today I'm not going to explain you about test bench, because what we do is after completion of this behavioral modeling, conditional statements and loops, I'm thinking to like conduct one or two sessions on this codes, like in order to clearly explain you about this codes clearly. Because here because why I'm not explaining this code clearly is because here I have used some of the things like u random, okay, u random range and repeat. Okay, these things I didn't explain you clearly, so that is why presently I'm not explaining this TB code, but in the next sessions I'm going to explain it clearly by executing them on the EDA playground. Don't worry about that. Okay, so this is the first conditional statement. What is that? If, else if, else. Okay, and then now comes the case statement. So why it has come to case statement? Because if you see it in the before before execution, for example, if we are having, for example, if you are having only four conditions, then in you will write if, else if and else. Fine, it is good. Okay, for example, in this 4 only, if you are having like some 10 conditions in order to get executed, then what happens? You can write it like this, but the code will be very large. Is it or not? It was also not appetizing to see. Okay, so that is why instead of if you are having more conditions to be executed, then we will go for case statement. So what is the case statement doing in case statement? Okay, this is the syntax for case statement. You will be writing case and end case is the keywords. Okay, there if, else if, all those are keywords. Similarly here case, whenever you are writing the case statement, you should use case and end case keyword. Okay, and within case you need to put the parenthesis. Within the parenthesis you will be writing the expression. That means what expression you want to write, you can write. Expression is nothing but the condition that you are going to give. Okay, so based on this, okay, based on the expression, you will be these case items, like any one of these case items, based on the expression they will be executed, and then it will be coming, it will be coming out of the end case. For example, if there are no if they and if not, if you are writing the expression but any of the expression is not got tallied with this any item, then what happens? It will be executing the default statement and it will be coming out. So combinational circuits. Okay, here I am designing a mux, right? So here always at the rate, okay, star. Okay, what is the meaning of this star? Okay, if you want to know about this always blog, I'll be linking that in the description box. You go and check it out. What is the star in this? What is the sensitivity list star mean in the always blog and all? Okay, so now I'm writing my case. Whatever you want to write, you should be writing within case and end case. Fine. So what is my expression here? SEL. SEL is the selection. Okay, now SEL is my expression. So based on the expressions, that means, for example, if you see here, if SEL is 0 0, what is this values you are sending it from test bench. Okay, where you are getting these values, you will be writing the test bench code for this particular marks, is it or not? So from that test bench you will be passing these values. So when SEL is 0 0, means the value is 0, is it or not? So when it is 0, the first value, that means this case is executed and it will come out of the case. Now for example, in the second time, when the SEL is 0 1, that means 0 1 is nothing but 1. So when SEL is 1, this statement is executed. If SEL is not any of these four conditions, okay, for example, if you are giving SEL value as 5, but here you are only putting the values like 0 1 2 3, but you are giving the value 5, so there is no expression that will be activated here. Now what happens? It will be executing the default value. What is the default value? In the default case, I have written $display invalid select input. So when you are throwing the value of 5 from your test bench to RTL, then what happens? It will be giving you the output that you, whatever input that you have given 5, that is invalid select input. Okay, clear? So this is how. In the similar way, you can write like JK flip flop also. If you see here, in JK flip flop, okay, so this is my JK flip flop values. This is my circuit diagram, and this is, if these are the values. So if you see here, when it is 0 0, when J and K are 0 0, QN means if it is having any previous value, then that will the same value will be continued without any change. And when J is 0, K is 1, the output is 0. And when J is 1, K is 0, the output is 1. And when both are ones, like when J and K inputs both are ones, then it will enter into toggling state. I think you know about the toggling state. Toggling state is nothing but, for example, the previous value is 1. Okay, then it enter into 1 1. That means after 1 0, you have given the input, you have given your from your test bench the inputs as 1 and 1. Then what is the previous output here? 1. It will be toggled. That means 1 becomes 0 in case of 1 1 state. Got my point? So this is my JK truth table. Okay, so based on this truth table, I am going to write my code. Okay, here JK flip flop. What are the inputs? Clock JK. Okay, JK clock along with reset. Right? So these are my inputs. And when coming to output, what are the outputs? Q bar. Okay, Q bar. Right? So now what I am doing is, all here just ignore these two values because I will be explaining it in the next slide. Okay, so as for now, just ignore this whatever that is written in green thing, and here always at the rate of passage of clock. So for every passage of clock, okay, what I am writing my code? If reset, if it is not reset, that means I am using the if condition. If there is no reset, then the Q value will be 0. Okay, since I'm beginning my case statement here. So case J K. Okay, now if you see both J and K and J are 0 0, then Q is nothing but Q. Nothing means, Q means whatever value that Q is already carrying, that value only is assigned to Q. When it is 0 1, 0. When it is 1 0, 1. When it is 1 1, Q equal to negation of Q. Simple. So based on this, you have given the condition and end case. Here you didn't give any default case. You can or you no need to give also for default cases. And then here, since you have begin it, okay, end. Okay, and then always at the edge. You need to see this begin and end. Okay, and then after that, here I am using SN. If you see here, this is my behavioral modeling and this is my data flow modeling. So you can use both behavioral modeling and data flow modeling at once in your code. But what is that you need to remember is, after completion of behavioral modeling, that means here when you are starting always block begin, you should end it. So before ending it, you can't assign it here. If you are assigning it here, it will throw you error. Okay, so after completion of behavior level modeling coding style, you can go for data flow modeling coding style, right? In the same way, you can go for gate level modeling also. You can mix match all the things, but in your module. But the only thing you need to remember is, first you should end the one coding style in order to start another coding style. Okay, what is this? I have given q bar equal to negation of q. Okay, that means here in the q bar I am just giving the value like negation of q and end module. Okay, so this is how I'll be writing my code for my jk flip flop. Got my point? Yes. So now, if you see here, I have written always at the rate passage of clock or negate of reset n. So what is this? Basically, you are having like two types of resets. I think you already know about that. So synchronous reset and asynchronous reset. Okay, for those who don't know about the synchronous and asynchronous reset, I am telling that if you already know about this, you can skip this part. Okay, so basically, what is the difference between the synchronous and asynchronous reset means, if if you want the simulator to only consider the clock value, ignoring the reset value, that means whatever the reset values, whether it is 0 or whether it is 1, if this doesn't take, if your simulator no need to take care of these reset values, then you can go for synchronous reset. Okay, synchronous reset means what is that? Here you are only synchronous reset is nothing, you don't add anything basically. Okay, synchronous reset means if you are giving only at the rate of passage of clock, if you see here, this is called synchronous reset. Okay, synchronous reset means you are not taking care for always, for this always block to be activated, it only need to take care of clock, no need of reset. But in case of asynchronous reset, this is opposite to that of synchronous. That means along with clock, it will also take care of reset of n. Now what happens here? If you see this always block, this will be activated for either passage of clock. If there is passage of clock, it will be activated, or if there is negate of reset, then also this will be activated. Got my point? This is the difference between synchronous and asynchronous. Okay, clear? Hope you got the idea of what is synchronous and asynchronous. If you are having further doubts, you can ping me in the comment box. Right? So, this is how the synchronous and asynchronous will be taking part. For example, if you want to write an asynchronous if you want to design someone asks you to design an asynchronous flip flop, then what you need to do for asynchronous flip flop, you need to consider both clock as well as reset values. But for synchronous flip flop, you just need to consider about the clock values. That's it. Okay, so that is the difference. Now this is the test bench code. I'll also explain this test bench code in the later classes. Okay, so this is the T flip flop. Okay, since we have already designed the D flip flop and T flip flop, you can just go through it. Okay, and if you are having any doubt, you can ask me. Here, if you see, I have used the conditional statement. I think you know about this thing. Okay, this is my conditional operator. Okay, within the conditional statements you are using conditional operator. Okay, so if you want to know about this conditional operator, I have explained that clearly in the uh, operators of data flow modeling. Okay, I'll also link that in the description box, you can go check it out there. Clear? So this is all for today. In the next class, we will be discussing about loops in Verilog. Okay, I think you already know about the loops, but there are some new loops in Verilog like forever loop, repeat loop. Okay, for and while loop, I think you already know about that. So I'll just give a basic descriptions on this for and while loop, and we will be seeing more about forever loop and repeat loop and what is the difference between forever loop and repeat loop. Okay, clear? So that is all for today. If you liked my explanation, consider subscribing this channel and also share this video to all the VLSI aspirants or VLSI enthusiasts, whoever also interested in Verilog. Also, I recently came to know that you will also have these concepts in your engineering also. So also share this to all your engineering friends who are also getting dilemma about these topics, right? Okay, thank you.